Hey everyone, geophysicist Stefan Burns here. We have just had a G4 geomagnetic storm. So we had a solar storm impact come in yesterday. It immediately triggered a G2 geomagnetic storm. There was an electromagnetic pulse from the shock of it because it was such a high density and such a high velocity. Then that storm cooled off, but then it ramped up today unexpectedly and we reached a G4 level. Boom shakalaka. And what happened during this G4 storm is that the entire power grid of Puerto Rico collapsed. It went offline. It looks like we have another 24, 48 to 72 hours before that gets repaired. They have a very weak power system there in general for the island. It's a private company and there's been ongoing problems there. So it's no real surprise that a strong solar storm is able to knock them offline. And also today with that G4 storm, we had huge outages with Zoom and also Spotify. So we had big problems with some big tech companies, and then also Puerto Rico, a territory of the United States, completely taken offline, and they are still without power at this moment in time to the best of my knowledge. So we are going to explore why this solar storm impact was stronger than forecasted. The original forecast is for a G2 by NOAA. Then they raised that to a G3 right before impacted based on some preliminary data that started to come in. Then in fact, it went to a G4. And so there is a reason why it was a G4. And we'll talk about that. And we'll also look into what's been happening in Puerto Rico and Zoom and Spotify. Kind of eerie because I talked about in yesterday's live stream with the initial impact of this solar storm about the effects of solar storm on power grids and technology. And I don't give that conversation every single live stream on a geomagnetic storm. I just felt like that was a good time to cover that topic. And well, it really seems like it was perfect timing. Also, what I've been talking about for the past couple days, past 2-3 days, anticipation of this solar storm impact and on yesterday's live stream is that we should expect some high magnitude 6+ earthquakes as a result of the overall energetic conditions here in our solar system. And well, about 30 minutes after that live stream ended, we had a magnitude 6.6 earthquake pop off. And so looks like everything is kind of working out. This model and understanding of the global electric circuit and how Earth interacts with space weather is really starting to become quite solid in our ability to forecast certain events unfolding on the planet. We just had a super thanks come in from Kristen. Thank you so much, brother. Love watching your videos. Thank you. Well, thank you, sir. Okay, so let's get into this solar storm. First off, though, let's go right to the New York Times. Massive blackout leaves all of Puerto Rico without power. And this basically happened, I think, like this morning or late last night. So it's not immediately clear why the generating plant on the island went offline. Of course, they have a history of this. But if we read over here, more than 1.4 million customers in Puerto Rico lost electricity on Wednesday. So this is today. And it began at 12:38 p.m. Near a transmission line in southern Puerto Rico. So that'd be Eastern domestic time, 12:38 p.m. And the work to restore the power would extend all the way into Thursday. It's not going to end today, according to them. We also have a post. Is it gone now? Maybe I lost it. I had it pulled up here, but I had a post from from the actual power company that operates as Luma Power, and they said it was going to take 24, 48, 72 hours. But I guess I exited out of the post on my browser tabs. But either way, this New York Times article is being updated actively, and basically they just go further on to talk about how the power system in Puerto Rico is really hit or miss, and it has been that way since 2017 after some hurricanes. So yeah, Puerto Rico, entire territory of the United States, completely offline, and it's perfectly lining up with this geomagnetic storm. They don't give a reason why, but we know that these geomagnetic storms can induce geomagnetically induced currents, which can cause these sort of voltage differentials to form, which can take a power system offline. We have a graphic here. We showed this on the last live stream yesterday. This is from NOAA showing the Geomagnetic storm impact scale. This was the original forecast for this storm, G2, which says like transformer damage is possible with a long duration storm. Well, this was a long duration storm. Keep that in mind. But really, there's probably not going to be too many issues. Then with the G3 storm, power system voltage corrections may be required. What does that mean? Well, you're running these different voltage differentials across power lines, and you're scaling that down, you're scaling it up, etc. Well, these geomagnetically induced currents, they also create voltage differentials. And if voltage goes over a certain level, it's going to cause a fuse to blow out or a transformer to blow out. And so they may have to actively correct for these voltage differentials that are being induced within these long conductor power grid systems as a result of the geomagnetic storm. So this was certainly a G3 storm because we had multiple hours where we were at G3 and G3 plus conditions. And then today we had 3 hours or so where we were at a G4 level. And so this is severe. Now the strongest is G5 extreme. We had that back in May of 2024. This is May 10th to the 12th. We also got really close to G5 back in October of 2024, the beginning of the month, around like the 10th or so, in general. So here, blackouts or complete collapse of power grids is possible, but here they're kind of, in general, more speaking towards like first world power grid systems. Puerto Rico's is really shoddy. And so with a G4 storm, possible widespread voltage correction problems on the power grid. Then you also get like radio degradation, satellite and GPS degradation. Well, we also had Zoom and Spotify have huge outages today, and more of these tech companies rely on satellite infrastructure. It's not completely locally based. And so that could explain why we saw these big outages also with some really very widely used tech systems, basically Zoom and Spotify. I'm sure there's probably other smaller ones that didn't really make the news, but they did. So let's look at this. Solar storm impact, the solar wind, so we can get a sense of what exactly this was, because it was pretty significant. Here's our real-time solar wind, and we're looking at the past 3 days here. And so I'm basically covering up the storm because I want to discuss ambient conditions first so you can understand the change that occurred. So here down below is our KP index, a measure of volatility in Earth's magnetic field, basically swings in the magnetic field strength registered at the surface. They take all the different magnetometer readings, they compile them into an index 0 to 9. 9 is a G5 storm. 8 is a G4 storm. 7 is G3. 6 is G2. 5 is G1. The most minor of the different categorizations. Anything below 5 is like active conditions, then to unsettled, then even to like quiet conditions like here. So we were in quiet conditions until all of a sudden this shock hit us. We'll see up here our interplanetary magnetic field. We see plasma density of the solar wind. We see plasma velocity, plasma temperature. Temperature went up. Velocity really went up. Density went up. You don't often, not every time, do you see velocity and density go up at the same time. There's some structures that if velocity goes up, density will drop down. So that double combo of faster solar wind and more dense solar wind caused like an EMP type effect on Earth's magnetic field. We see that all of a sudden we went to a 5, and then very quickly, if I step over here, we see that we had a good G2 storm where our KP values went to 6.33, and then things cooled off. Solar wind velocity went nearly to 600, or actually about to 600 or so. There are probably a few values, yeah, 640. And our density went all the way up to like 50. Look at that, 50 particles per cubic centimeter right there. Maybe I can get back on that value. Either way, that's very high. Whereas if we look here, our values before were less than 5 for density, and they were about high 300s for the velocity. So we had a 10x increase on the density at one point, going from before the storm to after. Now, if we zoom up here, we see our interplanetary magnetic field. The black line is effectively a measure of the total field strength. And then the red line is a measure of the vertical component called the Z component or the southward component. If it goes negative, that gives you a really good connection to Earth's magnetic field, and that's what can give you a powerful geomagnetic storm. So look at what happened after this initial shock, where a lot of the southward component was actually positive. So it was brushing off around Earth's magnetic field. We didn't have a real good connection, but just the sheer increase in the density and velocity caused us to have a G2 storm. Then things went, the solar wind was still very strong. We had values of about 20 nanotesla or so, which is 4 times stronger than normal. Normal is 5 nanotesla, but the southward component was sharply positive, but then all of a sudden it flipped and it went very negative, and our solar wind strength was still more than 3 times stronger than normal at 17 nanotesla, slowly decreased to 15 or so, and then it just flipped positive over the past few hours and the storm has come to an end. But we measure this here, that's going from about, let's say just 11 to make it simple, all the way to 1930. So that is 10 hours and 30 minutes where we had very strong solar wind conditions. Velocity slowly going down, density still staying high at about 10 to 15 or so. And then we ramped up very quickly. We see that we went back to G1 levels. Then all of a sudden we're at G3 levels right there, G2, G4. So 7.67 would be like a G4 minus. Only 3 hours of G4 conditions, but we still hit that. And right now we are still in G1 levels, but we're quickly coming down because our solar wind is, well, actually solar wind's 15 right now. So it was dropping for a while. It got down to 12 and that's getting closer to normal. Now the total strength is back to 15. So if this shifts negative again, we could get a third wave. But who knows? Whether it's likely or not, we know that we had 3 plasma filaments launched from the sun. This is definitely like 1 structure, 2 structure. Perhaps we get a little bit more. We'll just have to wait and see. We'll just have to wait and see. If we go here, let's look at our outages. So Spotify started having massive outages at about, what is this? 7 a.m. or so. It started before that, but 7 a.m. And normal baseline is like 4 outages. Even over here would be better for you guys. This normal baseline would be like 4 outages, and then we went up to about 50,000 outages. So again, 7 a.m. This is like Pacific time because it's going off of my clock computer. And then we can look at Zoom. And Zoom had it at about noon or so, if I remember right. Yeah, that's 11:59 a.m. Baseline is 4 reports, 56,000 reports. So that's incredible. Now, what's also incredible is this donation from Nino. Thank you so much, brother, for the very generous super sticker. Super thanks. That's incredible. Thank you so much. God bless. Welcome everyone to the live stream to what we're discussing here, which is this huge solar storm impact that we just had, how it triggered a G4 geomagnetic storm and the complete blackout of Puerto Rico's power grid, and also these technological outages with Zoom and Spotify. I'm your host, Stefan Burns, geophysicist, space weatherman, polymath, and more. So we had those outages. Again, it was around like 7 a.m. or so and 12 p.m. Let's go back to our real-time solar wind and let's zoom in right on those times there. So this is 7 a.m. right there. We see that's just during this this quiet period, but let's not forget we had this G2 storm. So the Earth was already shaken up as a result of this. The magnetic field is already more volatile. It was just starting to calm down. And then we see right at 12 there, that's well within this period of enhanced solar wind and that G3 storm right there. G3, that's a G3, yeah, G3 storm right there. So quite intense conditions that very well could be responsible for these outages. I think it's likely, just because personally I don't believe in coincidence. But make up your own mind. I think it's very I think it's very interesting that the timing lines up perfectly. And keep in mind that Puerto Rico also dropped at similar times. And actually, no, sorry, we did the math wrong. This is universal time right here. This time here is for PDT, I'm pretty sure, because it's showing like my recent time right there. If I was to refresh this, then this would go back. So let's do the conversion. Yeah, exactly. So this is PDT. So if it's showing 6 or 7 a.m., then that's actually like UTC. You have to add on like 8 or so. So we would go to 7, and that would take it up to about 3 or so. So that is right in the middle of this. So yeah, actually both of those outages are right in that like 10.5-hour period long zone there. So yeah, smoking gun, even better math. There we go. So yeah, smoking gun right there. Here's our HB60 index, a higher resolution look at the storm. We can see that our conditions effectively, so if I step off, they've been unsettled for a while, but in general, things were quite a bit calmer than this. Double pulse of activity really ramped up. We see our HB60 index actually went very, very high there. And we see that we're just now coming down off of this. Keep in mind, all this has biologic effects too. Earth's magnetic field has very, very, very deep integrations into our body biologically, bioelectrically, and it guides our circadian rhythm. And there's these normal diurnal variations that occur. There's these swings in Earth's magnetic field strength that happen as a result of the sun hitting the ionosphere, charging it up, and that generates electric currents, which create magnetic fields, which add or subtract to Earth's magnetic field depending on where you're located in the direction of those ionosphere currents. So northern hemisphere, southern hemisphere, near the equator, it's a lot to study. But regardless, these diurnal variations are maybe like 40 nanotesla or so. Earth's magnetic field is 23,000 to 67,000 nanotesla. So they're very small. They're like waves on the top of the surface of the ocean. Like if you have the entire depth of the ocean, this would just be like a small wave or something like that. Geomagnetic storm is like a storm on the ocean, something like that. The waves are much bigger, 400 nanotesla, 1,000 nanotesla, 1,500 nanotesla in terms of the swings in Earth's magnetic field strength. That's what induces these geomagnetically induced currents. But one question is, why was this so much stronger? You look at these configurations, and yeah, you have 10.5 hours of activity there, but the magnetic field wasn't 30 nanotesla or anything. It was only, 17 to 15. Well, A, long duration, 10.5 hours of perfect southward connection. That will really ramp you up. B, it was also after a period of already unsettled geomagnetic conditions because of the original shock. So we had that first shock, and that caused a G2 storm. Now you're already in these unstable conditions, and then you add on 10.5 hours suddenly of really good connection, and you'll move a lot of energy into the Earth magnetosphere, plastosphere, and this will really charge up the ionosphere. And that is C, is that we had the ionosphere very charged after we had this very active sunspot rotate on the Earth-facing side of the sun, continuously flaring for like more than a week. We can actually look at our GlowTech model to see this really, really clearly. Let's get this going. So basically what we're looking at here is the total electron content of the ionosphere, the uppermost part of the atmosphere. This starts around 50 kilometers up during the daytime. During the nighttime, it's about 100 kilometers up. It's about 1% plasma. So these are molecules that have broken apart into protons or into just like electrons or things of this nature. And so when you have all this energy coming in from the sun, it charges up the ionosphere. And it's the electric currents in the ionosphere, we see them here moving across, that generate these magnetic fields, which cause a geomagnetic storm, which then induces the geomagnetically induced currents, which can cause power grids to fail, whatever. You can also get charging of satellites and malfunctions to satellites and extra drag on satellites during a solar storm impact and a geomagnetic storm, which can cause problems, GPS degradation, especially in like the polar regions, the auroral regions. There's been some really good aurora. So, it's an excellent storm for any aurora photographers, I'm sure. But check out what happens right here. We are just now out of that G4 storm. And let me actually pause this so I can zoom around the scale, okay? Because here we see our conditions. Keep in mind our time there. This is like a 24-hour model. So this is right after this solar wind is hitting. And we see how it starts to really get enhanced, right? And now that energy has come in from outer space, from the solar wind, and entered into the ionosphere. There's a lag time, there's a delay, so it takes time to reach the ionosphere. But check out, like, especially like right here, how strong this ionosphere is with the total electron content, going a lot of it up to like 100, right? And then as you move further away, because of the poles and the tilt and everything, the total electron content drops. But just look how charged it is. Now keep that in mind. I'm going to go back 24 hours, okay? And that's it before. So see the difference there? This is it basically like now, and here it is before. Quite a bit stronger than before that impact. So that is another reason why this geomagnetic storm was stronger and actually did get to a G4, because the ionosphere was already charged up from that sunspot, and then we had those configurations, the magnetic field configurations, the long duration, and the fact that we already had a G2 storm shock hit right before. You get all those lined up, you can explain that 3 hours of G4 severe geomagnetic storming, and you don't need to evoke an explanation like Earth's magnetic field is weakening or anything like that. Though there's a lot of other stuff we could talk about too, like magnetic ducts through the ionosphere created from all the high frequency radio frequency technology like 5G. Also all the Starlink satellites, they beam down microwaves straight through the ionosphere to the surface. They have these wide beam swaths that they create. That also in general causes more of these ions to flow down. And something to keep in mind, now that this geomagnetic storm is probably over, though it could continue a little bit longer if the field flips back to the south, is that we are now looking at about the next 24 to 72 hours, some changes to the global electric circuit and to the overall flow of energy through the atmosphere. So there's changes to atmospheric pressure, and there's changes to cloud cover and temperature in certain spots, and zonal wind velocity in certain parts of the atmosphere. And in general, there's a very strong energetic connection going from Earth's surface, where we have these earthquakes, right, the lithosphere, to the troposphere, up through the stratosphere, and then all the way out even to the ionosphere and beyond. All of them are connected energetically via electromagnetic fields. And so when you get changes in one, you get changes in the other. And so we could be looking at enhanced weather systems in areas that already are more perturbed and have some weather over the next, I would say, 72 to 96 hours. It could start up really quick, but we see these sort of weather changes occurring after solar storm impacts and geomagnetic storms. We also we see this connection between solar activity and earthquakes. Let me go to our USGS map. On yesterday's live stream and the video before that, the day before, I was saying expect high magnitude 6+ earthquakes. We were in a lull period, we weren't having them, and then, well, 30 minutes after yesterday's live stream, this guy popped off, and that was right during that first shock impact of the solar storm. And so we had our magnitude 6.6, which is pretty significant. And we haven't had, this is set for 7 days, by the way. So we haven't had any other magnitude 6 earthquakes yet for the past 48 hours or so, just that one, but that's a pretty big one. We see it's actually the strongest earthquake of this entire 7-day stretch. We had this 6.5 that occurred on the 13th. I actually was forecasting that as well, because just in general, I was talking about how we had this reduction in solar activity and that we should expect more earthquakes. And then I also gave that forecast for the storm itself, because just creating more energetic change can also just cause things to kind of loosen up a little bit, and you may get a rupture. So it's imprecise science, you could say right now, but the forecasting that I'm doing on this channel does seem to rapidly be improving as I'm really starting to get my head wrapped around it. And we can actually type in, this is probably a good thing to do, volcano discovery so we can see this map, because I can show you the map. And maybe it's this one. No, it's not this one. I think maybe detailed stats will show us. Yeah, here we go. And we'll just load this up. Here we have our global seismic activity for the past 3 months. This is the global seismic burst that occurred right during and after the biggest coronal hole that we've seen on the sun in a very long time, about 10 years or so. We'll talk about that a little bit more. It's appearing once again. That coronal hole is going to be active on April 23rd. So this is a big storm, but we may have another one of these global seismic bursts as a result of that coronal hole in just like a week or so. So that was very significant. There's a rich body of literature that is talking, and exploring the connections between solar activity and earthquakes, and specifically coronal hole high-speed streams, which is what we have coming up in a week. And then we had this cool-off period there because that effect finally waned out. And then, but we had all this charging of the ionosphere from sunspot group 4055, which is now rotated out. And so after all that ionospheric charging, we know there's a strong connection between the lithosphere and the ionosphere. I said, hey, we should probably have some more high magnitude 6 earthquakes as a result. And lo and behold, there's that first one, there's that second one. So yeah, they're starting to come back. And yeah, didn't know about the outages. They're pretty wild. And so I think we may actually even have more elevated seismic activity going in all the way through basically the end of April. May 17th is looking really significant for a long-range forecast. May 17th, if we want a really long-range forecast, then January 6th or January 5th all the way to like January 15th or so is looking really significant. So that's based on planetary geometry, both of those. But you can keep those dates in mind. Log them down if you want. Remind me in X days. May 17th, around that time frame, and January 6th to the 15th of next year. That's a long-range forecast. Don't know how it's going to express itself, but I feel like there's going to be something then. I hope I'm wrong. But just based off of my studies, it looks significant. So I think that's it for, well, let's go back. We have 2 more things. We have, first off, some sunspots on the sun right now. 4062, 4064, I believe, and then 4060. This was very active before rotated Earth facing, and it's still definitely a big flare player. And these guys are also pretty significant. So we do have 2 new big sunspots on the Earth facing side just starting their 2-week trip across. And we'll see if there's any new flux that opens up, because this one actually just opened up like a week ago. It wasn't there not that long ago. Then all of a sudden, boom, that's a fresh sunspot. Hasn't had multiple rotations yet. And so in general, that's probably going to make it a little bit more likely to have active flaring because it hasn't expended its energy yet. Though there's so many dynamics at play, it's hard to give a precise pinpoint forecast for any particular sunspot. But we got these 2 guys that have 2 weeks now ahead of us. Effectively, I mean, more like 12 days for that one. But that's a long transit that we have for the rest of April, basically all the way for the rest of April. And then we also have this coronal hole. I want to show you this coronal hole again, though this time we will look at our 211 angstrom view of the sun. And we'll get this loaded up because this is basically the next big thing that we have coming up. So here we're looking at the past 72 hours of the sun, Earth-facing side. This is 211 angstroms. It allows us to see the solar corona very nicely. And so we see this really big coronal hole rotating in. This is the 8th rotation. We also see this really unusual, like, perfect circle appear in the corona. Check that out. I don't know why, like what that is, but it's just, this is just kind of captivating my imagination. It's like a perfect circle. It's very bizarre. And it's like this vortex or something too. So that's bizarre. I don't know what it is. It's a small feature, though you could fit probably a couple Earths in there at least. But that's pretty bizarre. You can see like this rotation on it. Check that out. See, it's like growing, and there's like this like rotation to it. Yeah, do you see the little light swirl at the very end? Let's watch that one more time. If you watch right then before it gets jerky, because the camera is doing some sort of calibration or something, there's like this light swirl that's going like this, like a very low grade flare that's like spinning. Check that out. This is weird. Yeah, I'm just looking at this for today's data. See that? Yeah, that was weird. Okay, but this is what we have coming up April 23rd, this big coronal hole, and that's very likely to influence us in terms of the solar wind, and probably will give us a geomagnetic storm. Last time it stretched across the equator, and we had a bit of this coronal hole also up here. Now it's more concentrated to the south. It's not as large as it was last time. So it is possible that this high-speed stream mostly passes to the south of the Earth. But I have a feeling that this is still going to interact with us. And so that's coming up in 1 week. It's going to be geo-effective in 1 week, but that's a big boy. You know, it has decreased since last time, but it also kept growing on the 7th rotation until it was right Earth facing directly in that center zone. It was growing the whole time. So, you know, we have this coronal hole up there. We see a little bit of darkness there. I wouldn't be surprised if we had this weirdo thing there. This is actually looking like it's getting darker as we speak. So this could be just as significant as last time. It very well could be. And yeah, so we got some wild stuff happening. Thank you to everyone that's given super thanks over the past, you know, for the live stream. Like I just see Christine gave a $5 super thanks. So thank you so much, Christine. And with that, let us start the question and answer. If you have a question as to what is happening in terms of the energy here on Earth, space weather, this solar storm, why it's causing these sort of problems, anything like that, then please type @Stefan Burns. I'll answer your question. Anyone that does a super thanks and puts their question in that gets priority, just because that's the fair thing to do. But I will do my best to answer a wide variety of questions. Let's try to keep them on topic. So if they're wildly off topic, I'm not going to answer them this time. So please, you know, stay on topic. Thank you so much for understanding. And yeah, if you have any questions, you can type @Stefan Burns, and I will do my best to answer them during this question and answer. And let's also load up our 171 angstrom view of the sun. I like this view because it shows these coronal loops really nicely. So Rama Lama, who's a very generous donor, asks, why do you think some of us feel these symptoms right before the storms? Well, before a significant coronal mass ejection, there can be a ramp up in low energy protons and electrons. And so I can show you that really quick. And that could explain why. So if you go to our products and data, we can go down to our ACE real-time solar wind. This is another probe that they have out in space, but it's it's the older one. And so they also collect low energy proton and electron data. So let's actually make that 7 days. But see this ramp up? That occurs right before the coronal mass ejection, and then it'll fall off as that solar storm hits. And so if you're very energetically sensitive, this could be one explanation as to why you're feeling it. You know, this is a very nuanced thing. It's very individual. You know, there's a whole bunch of factors to it, but this could be one explanation why. That is obvious, at least to me. Questions, if you have questions, again, type @Stefan Burns. Question from Say Ray is, do you think we'll see a G5 storm in 2025? I do. I do think we'll see a G5 storm. I mean, I have these long-range forecasts, which I can't say I'm like 100% confident on, like, guys, the world's going to end. That's just not that's not how I work, right? I think we should have a little bit of humility in things and not get ahead of ourselves as humans. We're pretty insignificant at the end of the day. But if we study planetary geometry and significant geometry and the angles of the planets, that seems to correspond with storms. We have really big planetary geometry coming up at the very beginning of 2026. But we also have some really significant geometry with May 17th, and I haven't looked beyond that. Just in general, this entire time frame has some really significant geometry because of the fact that we have a Saturn-Neptune conjunction right now, the reset of a synodic cycle between Saturn and Neptune. And based on some other factors, yeah, I do think we have a G5 storm set and ready for 2025. When though, that's a good question, but I would be surprised if we don't have one. Let's just put it that way. I would put money on that. Do some of the sunspots that are turning towards us in about a week look like they are about to shoot a flare off? Right now they look fairly stable. We see them rotating in here. This isn't the absolute best view to look at it. That'd be the 131 angstrom view, but still we can see their activity pretty nicely. That one's looking pretty active. And we see the one behind it. So they are quite active, but it's very possible that they are big flare players. It looks like there's a little bit of diminishment in their activity just in the past 24 hours, but they're big sunspots, and yeah, they could be close to shooting a flare out. It's really hard to say with solar flares when they occur, but generally if there's a lot of activity, then that's a good sign that you have a higher likelihood of there being a big flare. Luna is asking, what is worse, BZ North or BZ South, and what is the difference, please? Yeah, so that's fairly simple. BZ South would be worse if you're talking about a geomagnetic storm. BZ is the vertical component of the magnetic field for the solar wind. Also, Earth has a BZ component. B stands for magnetic, Z is just the vector direction. And so Earth's BZ is always positive, whereas the solar wind can be positive or negative. And when it's positive and you have Earth's positive, they kind of don't connect. And so it just flows around the Earth. You do get some energy entering at the magnetotail, but in general, this kind of sloughs off around the Earth. Earth is Teflon. But the BZ South, now they have this good connection, and that brings the magnetic field in closer to the Earth and causes a lot of energy to enter into Earth's magnetic field, the plastosphere, and that's what makes the geomagnetic storm possible, the flow of energy into the plastosphere, into the ionosphere, making those stronger electric currents, which generate those stronger magnetic field swings. That's the whole equation. So yeah, negative BZ is definitely worse. And Lisa is asking, could these storms affect people physically? The answer is yes. I have a playlist actually. If you go to my channel page, you go to playlist, I have a playlist on how solar storms and electromagnetic fields influence health. And these are like 3 long, like 1 hour long lecture presentations that I gave. So find that playlist and watch through that if you want to understand how this affects us physically, biologically, bioelectrically, and more. We go through solar storms, we go through geomagnetic storms, and we go through we go through solar flares and solar activity. We go through geomagnetic storms. We also go through EMFs. And the Sally Kite, or Kate, the Sally Kate, is asking, do you think it's possible for the grids to overload with a constant electrical build up in Earth's atmosphere rather than with a big punch? Yeah, so I mean that's kind of speaking to like Earth electrification, and if we get Earth to get more and more electrified, then that's just going to put in general more stress on technological systems. But there is going to be, because it's more constant, you could say even chronic, then there's going to be ability to perhaps adapt to that. I think it's always going to be the sudden change, the big punches that really can trip things over. But we see the Earth is becoming increasingly electrified, and our technology is actually making these things worse based on my research. Cellular signals and cellular networks, power grid, harmonic line resonance, and all the satellites are definitely contributing to Earth electrification and likely going to make these solar storm impacts even more significant across time. So yeah, we're basically doing this to ourselves based on my research. Do your own research, please. I think it's really important to do. And Josh is asking, why is the data 3 hours from NOAA anyways? What's the best place to find live data? Well, the real-time solar wind is live. You go to type in HB30 index on Google to pull up the GFC Potsdam data. That has a 30-minute resolution for the geomagnetic indices. And that is higher resolution. I would say the 1 hour index is what NOAA should use, but they use the 3 hour. That's the standard. You know, there's an inertia to these things. And so they're just developing these higher resolution ones recently, whereas the KP index has been used for decades and decades. And so it does make it useful to compare across longer time frames and also just longer data sets, it's easier to work with the KP index. So that's my basic understanding as to why. Steve was asking, are you familiar with the solar system shift and how each planet's fields are reversing too? Yeah, I'm not. I have no evidence. I haven't seen any evidence of that occurring. We have to keep in mind that we have such limited data for the other planets. We've had a single flyby of Pluto with New Horizons. We've had a single flyby of Uranus and Neptune with the Voyager probes. We've had multiple flybys of Jupiter and Saturn. We have permanent probes there, but we also have to consider the fact that we've only been looking at the planets in terms of like active space exploration since the 60s, basically. So I think it's actually the 70s. So the solar system is millions of years old, billions of years old, and we can't really draw any meaningful conclusions from 50 years or, 50 years of data. So it's really ignorant of us to think that we can. And then the same, Venus, Mercury, Mars, we don't have that much data on them. We have MAVEN around Mars, which collects data, but it doesn't have a magnetic field. Magnetic field for Mercury is pretty weak. It's only 1% of Earth's. I don't know of any evidence of their magnetic fields reversing and that there's some coordinated reversal. And you can simply it's really simple. We don't have to get lost in the weeds and therefore, fall prey to like these nuanced attacks or tricks or anything. Like we only have 50 years of this data and the solar system is millions and millions of years old. And so our understanding of this, these reversals on Earth, at least for the magnetic field, take like 1,000, 2,000 years to like lock in. So we're looking at such a small slice. How can we draw any meaningful conclusions from that? I think that's very simple, but feel free to do your own research and you can disagree with me. We have a question from Sean, a very generous super thanks. Thank you so much, bro. God bless. Sean is asking, will any of the upcoming disclosures by government measure up to 9/11 energy and what instrument measured that event? Your best guess is appreciated. So what Sean is referencing, I think, is like the Global Consciousness Project and how there's these random, or something like this effectively, because he left out some details, it seems. But I think I understand what you're getting at. So there's, for example, the Global Consciousness Project, where there's random number generators all around the world. And it seems, the research shows, with an incredibly high statistical significance, like incredibly high, that when there's meaningful mass events around the world, like 9/11, the random number generators enter into greater coherence with the numbers that they're spitting out. All of a sudden, they start spitting out the same numbers, basically, to a greater degree. And so, will there be any upcoming disclosures by government that measure up to 9/11? Well, we're in the years for it right now. 2025 and 2026, again, are very, very powerful years if you go by the planetary resonances and the archetypal energies that are active at this moment in time. And so I wouldn't be surprised. We also have 2032. That's another big date as well for planetary resonances. 2028 is another one as well, though not as significant, but really 2025, 2026, and then 2032. And then there's actually really not that much all the way until 2040. So those are like the three key years, 2025, 2026, 2032, and then we have to wait all the way to 2040 until there's other key planetary resonances. If we go just off of that, we also have solar cycle maximum, which influences people, makes things a little bit more volatile and active. We see spontaneous social processes, aka revolutions, happen during solar maximum. We see more economic instability during solar maximum. So we have solar maximum that will occur in the late 30s, 1930s. This one will end around 2027 or so, really be in the descending phase by 2027. So those are some dates for you, but in terms of specific dates or what the government's going to disclose, that's another big question. But yeah, that requires some previewing of the conspiracy theories and everything. And I definitely do that. For a while there, they were basically spoilers 6 months in advance. It's beyond the scope of this video, but thank you so much for the generous super thanks. And I can see something dancing around below the rotation thing on the sun. Can you check it out? Okay, let's see what you're talking about. So we're talking about this weird circle that we were looking at earlier. And the Highland Space Weather Club 2.0 had to be rebooted, saying that they're seeing something strange right below it. Yeah, there is a plasma filament right there. That's a plasma filament. So the fact that this is like undergoing this rotation, you know, we could get this to destabilize. Yeah, we could get that to destabilize. That's a plasma filament. This is a small one, but that could launch out towards us because it's getting fairly close to Earth center and direct. And Kuneberger is asking, can you address the flickering lights on Earth? Could they be from frequencies from the sun? So it could be like, for example, ball lightning or little plasma orbs. We know those exist. But also, just to say, like, you have to take a huge grain of salt with any sort of viewer submitted video, because I mean, I've had people submit me videos of like UFOs. We also saw a ton of this floating around on the internet during the New Jersey thing. And a lot of those videos are actually people pointing their camera at Venus, totally zoomed in. So they're seeing the atmospheric distortion. And that's because Venus was a really bright evening star at the time. And a lot of people just don't even understand their own celestial backyard anymore. So they don't know what they're looking at. So I wouldn't be surprised if a lot of those are actually just like, for example, Jupiter is really bright in the sky right now. Sirius is really bright. They're both low on the horizon. I can see people mistaking the two of those for flickering lights, actually just the stars themselves. Most people now are in light polluted areas, so those are the only two lights that they may see. And most people don't have an education on this. It was much stronger back in the 70s and the 60s because, you know, the space race. You know, there was a public interest and excitement about this. It's coming back through the efforts of, you know, people like myself and many, many others. But in general, there's a lack of education on this. So I can't really, you know, there's plasma cosmology, and we see that there's definitely like plasma orbs and things that sometimes appear in our atmosphere. So that's one likely explanation, but there's also certainly going to be a bunch, like a large percentage of those sightings, I would bet, would be people pointing their camera at Venus or Jupiter or Sirius and just not knowing what they're looking at. So yeah, you have to look at these things with a huge grain of salt when it comes to like viewer submitted videos. And I don't, if this is a point, parking lot lights and street lights, I don't know what that means. I mean, these LED bulbs also, just FYI, like, you know, they're rated for 20 years and they're failing at like 5 or 3 years. So there's significant problems with like LED bulbs that a lot of these companies or businesses or governments, like, you know, the city or whatever, bought pretty early on because it was a new technology, and LEDs are amazing. And well, guess what? That 20-year lifespan was actually basically a lie from China or whoever, and they're only rated for like 5 years, and now it's a lot of work to replace them. So they have to go through the entire city now and replace the street lights. So I'm not sure if that's exactly what you're talking about, but I know that's also a factor at play. Yeah, so that's probably what it is, because I've seen that myself, and that's just an LED problem. That's a pretty simple explanation. So we'll call it, we'll end it there. Thank you all so much for watching the live stream. This is what we have coming up next. April 23rd is when that will be geoeffective approximately. You know, add about a day onto that perhaps. But that is the next big thing. We just got out of a G4 geomagnetic storm, and that was quite a doozy. Knocked Puerto Rico offline, also caused outages at Spotify and Zoom. So really significant enhancement of the energies here on Earth. Here's that data one more time. We have our real-time solar wind, and we see that storm come in, and wow, what a doozy. A double pulse of energy. We explained why that was as strong as it was. And in general, again, because of the current energetic conditions that we have, I would not be surprised if you see more high magnitude 6+ earthquakes. We're also, as I've been saying, we're 3.5 years into not having a single magnitude 8+ earthquake. So we are overdue for megaquakes. We usually get one a year, and we haven't had one in 3.5 years. So that is what's happening. I've been your host, Stefan Burns. Thank you all so much for watching. If you'd like to stay up to date with what is happening with the Earth energetically, then you have found the right channel. I examine what's happening with the Earth geologically and geophysically. So this means earthquakes, this means volcanoes, this means weather, ionospheric disturbances, things of this nature, the global electric circuit, which very few people talk about, but it's like the one unifying factor for all this. But then we also go out to the sun, examine solar activity and what's happening with the planets, planetary resonances, cosmic forces, and more. I bring that all together, present videos almost daily. If you like the sound of that, then please subscribe. We also talk about how these energies affect us, our health, our wellness, and our consciousness. So if you like all that, you are in the right place. Thank you to everyone who joined in on the live stream today. 4,000 people at the top, which is incredible. A lot of questions and super thanks and support and love. And we have hit 222,222. So that is incredible. Really a really wonderful, fortuitous sign, I would say, for all of us here, part of this community, and you can be a part of that too, and take us to 333,333, which is like the Holy Trinity number. So let us go now to the next big angel number milestone, and I'll see you all in the next live stream.